Neptune Trojans were only just discovered in, I think the first one was discovered in 2003 by a survey that was covering a big area of the sky. And then we went and detailed, looked for more of these Neptune Trojans, and we discovered 8 more since then. These objects share an orbit with Neptune. They're about 60 degrees ahead or behind the planet, and that's the area where the gravitational forces from the sun and the planet kind of cancel out. On the Neptune Trojan regions, there's 9 of these objects known, but they're expected to be larger than the main belt asteroid population, so there's expected to be hundreds of thousands of these objects out there, but most of them are very faint. We've been using some of the largest telescopes with some of the largest cameras in the world to find them. And so the telescopes that we've mostly been using is the Magellan telescope. It's a 6.5 meter telescope in Chile that is owned by the Carnegie Institution. And then there's the Subaru telescope, which is an 8 meter telescope in Hawaii, owned by Japan. We take 3 images separated by about 2 hours each. So there's about 4 hours between the first and the last image. And you blink those 3 images, you can see the motion of the object, and that's how you find them. The reason I'm interested in the small bodies in our solar system is because they have a fossilized imprint from the formation of our solar system as well as the migration and evolution of the planets. We can determine how our solar system formed and how it evolved over time just by looking at objects that are currently out there in our solar system. It's kind of like archaeology, where you go, you see how things are now, and you can figure out what happened in the past.